So the first question, solution A and solution B are aqueous solutions. The compound in each solution contains one cation and one anion. The cations are different, but the anions are same. Give the formula of the three cations that could be responsible for the green color. So it's a solution, aqueous solution is there. So if an aqueous solution is green in color, what could be the cations present? The aqueous solution. So it might be aqueous chromium, or it might be vanadium 3 also, that is aqueous, and chromium 3 also, aqueous is green, iron 2 is also green, nickel 2 is also green. So, and in aqueous solution, how the transition element exists? Transition element exists as a complex. So, for example, if I have a chromium compound, say chromium 3 chloride. So when I dissolve this in water, like if it dissolve, it will be chromium plus 3 charge and chloride minus. But this chromium 3 does not exist as an ion, a single ion. It is occupied by, like surrounded by 6 water molecules, which will form a complex. So as a result, there will be a formation of a complex or a dative bonding. So we might have a chromium, which is surrounded by water molecules, and the net charge on this complex will be plus 3. So this will be a chromium plus 3. Same thing, it might be vanadium plus 3 because vanadium also, its solution is green. You have to memorize the color of the solution from the book. It might be nickel, the aqueous complex of the nickel 2, or it might be iron 2. This is how the complex ions will exist. But it is acceptable if you write only the charge on the ion, like chromium plus 3, vanadium plus 3, nickel plus 2, and iron plus 2. The next is a student added dilute aqueous sodium hydroxide drop by drop in each solution. Yeah, samples of the each solution. Initially the green precipitate were formed, and more aqueous sodium hydroxide is added until the sodium hydroxide is in excess. The precipitate produced from solution A are insoluble and turned brown on standing. So this give an indication that actually it was iron 2, because first it was iron 2 solution was there. When we add sodium hydroxide or alkali, what reaction happened? The first reaction is acid-base reaction, like deprotonation of the water molecule. So 2 water molecules will be removed, so it will form FeOH in a bracket 2, and it will form H2O4. So as a result, the net charge on this is 0. So if net charge on the complex is 0, it will form a solid. So this will form a brown PPT, brown precipitates. And why these brown precipitate, this form a green precipitate. Why these green precipitate turn brown on standing? So the reason is that because iron 2 will be oxidized to iron 3. So first the formula for the green precipitate, and then white turned brown on standing because iron 2 can easily oxidize if we shake the mixture. Iron 3 can easily oxidize to iron 2 can easily oxidize to iron 3. So this will be FeOH in a bracket 2 and H2O4. This will be the formula of the precipitate. It is acceptable if you write FeOH2, that is also fine, iron hydroxide, because that is correct as well. But the actual one is this, like it formed as a complex. Then the second one, the precipitate produced from B dissolved. So if we have a green precipitate and we dissolve in excess, so what this give an indication? This give an indication that it was actually chromium, the solution. Because chromium It dissolve in excess. Give a formula responsible for a dark green solution. So if we need a solution, not the precipitate. If they ask us, like example, first the chromium was there in an aqueous solution, it was forming a complex that was the net charge on the complex was +3. First we add sodium hydroxide. So hydroxide ion, again acid-base reaction. So it will form chromium OH3 and then H2O3. This will form the precipitate. But then in excess, like we add more than enough. So because some of the hydroxides are amphoteric means they can react with uh, base as well or acid, both of them. So chromium hydroxide is amphoteric. As a result, if we add more hydroxide ions, there will be another reaction, again acid-base reaction. So this chromium will turn into, what will the net charge? Chromium is +3, hydroxide is -1, 6 will be -6. So the net charge will be -3. And that this reason why it dissolves, because the net charge on the complex is negative or positive, so it will dissolve. If there was a net charge 0 on the complex, then it will be a PPT or precipitate. In part C, student added hydrogen peroxide. Hydrogen peroxide is an oxidizing agent. It oxidizes the substance. The solution C was warm and then it turned yellow. The yellow solution was boiled to remove excess of a hydrogen peroxide, because hydrogen peroxide on decomposition, like when it decomposes into water and oxygen. So if we heat it, it will decompose fast. And we cooled and then ethanoic acid was added. A yellow solution turned orange. So why in this case there is a color change? In this case there is a color change not because of change in oxidation number. In this case there is a color change because there is an equilibrium between a chromate and a dichromate ion. Like if we have CrO4 with a charge, chromium -6 +6 is there, and dichromate Cr2O7 with a charge -2. So to balance the water, to balance the oxygen, we add water molecules, so 3 water molecules. And the reaction is reversible. To balance the hydrogen, we add proton. So there will be equilibrium between these two. In acidic condition, equilibrium shift toward left. In alkaline condition, equilibrium shift towards right hand side. So this color change in a chromium is not due to change in oxidation number. It is just a shifting of equilibrium between the chromate and the dichromate. State the type of reaction occur when the dark green solution turned yellow. So dark green, it was chromium 3. When we add a hydrogen peroxide, an oxidizing agent, it will turn into chromium +6. So chromium will be oxidized and hydrogen peroxide will be reduced. So this reaction is, you can mention as oxidation reaction, or you can also mention a redox reaction. Identify by name. I am responsible for the final orange solution. So that is actually a dichromate 6, Cr2O7 with the charge -2. Because the equation for Cr, like we have a chromate ion CrO4 with a charge -2. This should be 2 here. Reason is that to balance the chromium Cr2O7 with a charge -2. Oxygen is 8 here, oxygen is 7, so we should add water at this side. And then the proton other side. So when we add an acid, equilibrium shift towards the right hand side. As you can see, pure ethanoic acid is added. So if we add an acid, equilibrium shift towards the right hand side. This is orange in color and the chromate ion is yellow in color. Chromate 6 is yellow, dichromate 6 is orange in color. Pure ethanoic acid is corrosive. Acids are corrosive. Identify the appropriate control measure to reduce the risk associated with this hazard. Assume that the student carry out additional fume cupboard and wearing glasses, safety glasses and the lab coat. So how we can minimize the risk when we are using the acid? As they did not mention here anything related to the gloves, so we can mention gloves as well. Another thing, because acid, we are handling the acid, so we should use low concentration, like small scale or low concentration. Or we can also use, like example, adding an acid to a container, so it should be a large container. Say, if we want to add 50 cm cube of acid, example, so we should use 250 cm cube container so that it minimize the risk. But the safety precaution, the main safety precaution is use gloves is the main one because it's not mentioned here. Describe the corrosive hazard level um, present on the bottle containing pure ethanoic acid. You may use diagram. So usually as acids are corrosive, so when something is corrosive, what is the symbol used, the label used for the corrosive? Like if we have a metal and acid is added, it will come in contact with the metal, it will be corrosive. Or if the metal is, another test tube is there, and if it will come in contact with the hands, that will also be referred. So whenever it is corrosive, like two test tubes which are there, which shows that acid core, and with metal and with hands, both cases, it will be. So hand and a piece of a metal will be there on the bottle. And if it was oxidizing, so there will be O and then the flames. This is oxidizing. But if it was flammable, only the flames are there. These are the labels on the bottles. You have to learn these labels. You can find the first chapter of the book, you can find these labels. The beginning, start of the book. The student attempt to identify an ion present in the green solution A. The student added a nitric acid and silver nitrate. This is a test for halide. A pale precipitates, light color precipitates are formed that might be white or cream. Identify the two ions which are responsible. So it might be because white is due to chloride and cream is due to bromide. The precipitate form was separated from the mixture and aqueous ammonia is added. Describe how to how this test allow. So if we add aqueous ammonia, if it is dilute or concentrated, chloride will dissolve. But if it is constant dilute, bromide will not dissolve. It will only dissolve when concentrated. And iodide precipitates does not dissolve. So if we add aqueous ammonia or ammonium hydroxide, and if it is dilute or concentrated, if it is dilute, the chloride precipitate will dissolve. Bromide precipitate will not dissolve. If it is concentrated, chloride will dissolve, bromide will also dissolve. So what we should do? We should add a dilute aqueous ammonia. If the chloride precipitate, it does not dissolve. With bromide, it will, if chloride will dissolve, but the bromide does not dissolve in dilute. Explain why the solution A, the precipitate must be separated before adding aqueous ammonia. Like why we should filter off? Because what might be the reason here that the solution A is already a colored solution. So that result might interfere because like solution A, we already identify solution A contain iron 2 ion and the other ion might be chloride, maybe bromide. And when it form as when we add aqueous silver nitrate and nitric acid followed by silver nitrate, so it will either form, if it was a chloride precipitate, it will form AgCl. If it is a bromide precipitate, it will form AgBr. Now, why we should filter off? Why not adding into the same? Because if we add aqueous ammonia, if aqueous ammonia is added, the iron will also form the precipitate. So it might form precipitate due to iron, 2 ion, which will form a green precipitate that will make it difficult to recognize whether the precipitate of silver are dissolving or no. That's why first it should be filtered off, and then we should carry out separately on the precipitates. Question 2, the reaction between the tertiary halogen alkane, 2-chloro-2-methyl propane and hydroxide ions form methyl propane 2-ol as shown. The progress of the reaction can be followed by titrating the portion of a reaction mixture with solution of hydrochloric acid of a known concentration. An experiment determined the order of a reaction was carried out. The procedure, a flask containing 250 cm3 of ethanolic solution of 2-chloro-2-methyl propane. Why halogen alkane? Why we use alcohol? Why not water? Because halogen alkanes are not soluble in water. Halogen alkanes are not water soluble, so that's why we use alcoholic solution. Then similar flask containing 250 aqueous sodium hydroxide, and then we place the same water bath. Why we heat them? Like water bath at 25 degree was there. Then 7 conical flasks were prepared. Each contained 50 cm3 of propanol. The reaction was started by mixing the two solutions from the water bath in the large flask and then returned to the water bath. And the timer was started, and as the solution were mixed. After intervals, 25 cm3 of a sample was transferred into a conical flask containing propanol. Each sample was immediately titrated with a solution of hydrochloric acid, methyl orange as an indicator. Give the expected color change at the end point. Methyl orange is there. So originally, because what we have, reaction mixture was transferred into a conical flask and sodium hydroxide was there. So unreacted sodium hydroxide, so alkaline solution, what is the color of methyl orange? It is yellow in color. And we are adding an acid because it is titrated with HCl. So when we add an acid, so sodium hydroxide will be neutralized by the acid, and the solution, neutral solution will be there. The color of the neutral solution will be orange. So color changes from yellow to orange. Explain the effect on the volume of a hydrochloric acid required if the titration was not carried out immediately in step 4. So what actually is happening here? The main purpose of adding a propanol is to slow down the reaction, like it is quenching. But if we don't carry out the reaction instantly, then what will happen? The sodium hydroxide which was used here, this will react with 2-chloro-2-methyl propane. So there will be a reaction between them. As a result, what will happen? The amount of sodium hydroxide in the solution will decrease. So we need less amount of hydrochloric acid for the titration. Because sodium hydroxide is an alkali. Sodium hydroxide is reacting with this halogen alkane. Explain how the use of aqueous ethanol in the reaction mixture allow the reaction step 3 to proceed relatively faster. Description of a force involved is not required. It's the same idea, because what will happen? Halogen alkane can dissolve like in alcohol, and aqueous sodium hydroxide and alcohol are miscible because lower alcohols, as they can form, you don't have to mention the hydrogen bonding, but ethanol can mix with the water or aqueous sodium hydroxide because like water is present. So as a result, both of these reagents like sodium hydroxide and like 2-chloro, 2-methyl propane, they can react with each other. So what you will mention as a point, you will mention like alcohol can dissolve or mix with aqueous sodium hydroxide. Alcohol can also dissolve 2-chloro, 2-methyl propane. So as a result, the two substances, the two reactants can mix in the solvent and react. Otherwise, if we use 2-chloro, 2-methyl propane and we use aqueous sodium hydroxide, so they are immiscible. So as a result, it will form two layers. But in this case, it does not form two layers. Experiment was carried out using a procedure. The results are shown. Volume of a hydrochloric acid and the time was there. So you have to plot in the beginning. In the beginning, as you can see, we need more hydrochloric acid, but with the passage of a time, hydrochloric acid amount decreases. The time scale is in second, like, but it is 50, 320. So, like if it is, this is 1000, 2000, 3000, 4000, and 5, 10, 15, 20, but this will be so small. If it is 10, 15, 20, also small, 5, 10, 15, 20, 25. So this we can do like 5, 10, 15, 20, 25, and then 30. So the graph will be somewhat like in it's 24.5 and 50. So 10 boxes. So 10 boxes equals to 500. So each is equals to 50. And here 10 boxes equals to 5. So each is 0.5. So this will be like 24.5 some here. So and then 22 and 320. This will be 1000, 1500, 2000, 2500, 3000, 3500, 4000, 4500. Then 320, and this will be like 300 will be 6 boxes, and then 22, 21, and 22. 300, about 320 here. So the shape of the graph somewhat like this. And if the half-life is constant, means it will be first order. If the half-life is like in the beginning it is shorter, but then with the passage of time it gets longer, then it will be a second order. Determine the two successive half-lives and state the order of the reaction. Justify your answer. So you have to work out the half-life. If the half-life is constant, it means it's a first order. If half-life is not constant, it means it is a second order. So you have to work out the half-life. So these are question 1 and 2 from